These are the notes for the attributes of parallelograms that you discovered and discussed in 6.7. So the first parallelogram we're going to talk about is straight up parallelogram. We're going to discuss the attributes that the sides have, the angles have, and the diagonals have. So in a parallelogram, we say that both pairs of opposite sides are parallel, and that's that lovely symbol of two lines is parallel. And you'll remember that when we initially did these definitions, we indicated parallel by having these arrows. One arrow means these two sides are parallel. Second, two arrows mean those two sides are parallel. The second attribute is that the opposite sides are congruent. And again, you'll remember that congruence we use by these little check marks. So one check mark means these two sides are congruent, and two are going to say these other two sides are congruent. Not that they're congruent to all of them to each other, just the opposite sides. Similarly, we discovered that with the angles, the opposite angles are congruent, and that's again symbolized by this equal sign with a little squiggly on top. So we say, yeah, that angle is congruent to that angle. Those are opposite angles. And that angle is congruent to that angle. And again, one tick mark indicates these two indicates these two. So I can very clearly show that it's not that all four are congruent. And the last thing that we discovered is that diagonals bisect each other. So I have one diagonal, two diagonals, and bisect means cut in half. So these two pieces are congruent, and these two pieces are congruent. You then moved on and talked about rhombuses. Rhombuses, the attribute that they have for their four sides, are that they are all congruent. Again, I'm now using some shorthand here. Equal sign, squiggly, means congruent. So instead of having one side have one tick mark and the other sides have two, I can say all four of them have the same tick marks. Rhombuses have the same characteristic that parallelograms have with their angles, because they're also parallelograms. And so we can say that the opposite angles are congruent. Now the diagonals in a rhombus actually have some different characteristics. First, the diagonals are perpendicular bisectors of each other. And what that means is that the diagonals do exactly what they did in a parallelogram. They cut each other in half. But they're also perpendicular, meaning that the two diagonals form right angles. So each of these angles are right angles. We only mark one because then the picture becomes a little too messy. Also, the diagonals in a rhombus bisect the angles. So we have our diagonals. And so now we have that this angle is congruent to this angle, and this angle is congruent to this angle. Now remember, the angles in a parallelogram are the congruent, the opposite angles are congruent. So if these opposite angles are congruent and the diagonal cuts them both in half, then all four of these angles are going to be congruent. And that same thing works on these four angles. The next special parallelogram that you looked at were rectangles. The rectangles, we're going to keep referring back to other figures here. So the rectangle is the same as the parallelogram. So opposite sides parallel, opposite sides congruent. Now, in this case, with the rectangle, the angles do have a slightly different property, which is that all four of them are congruent, which makes all four of them 90 degrees. The diagonals have the characteristics of the diagonals in a parallelogram, but they also have an additional quality, which is that they are congruent. So this diagonal and this diagonal are congruent. In this case, it'd be really helpful to name the parallelogram, A, B, C, D, and then to actually say that AC is congruent to BD. Putting tick marks in this diagram is a little confusing because we have this place where it gets cut in half. And so it's harder to see what is happening. So the other attribute is that the diagonals bisect each other. But in this case, since the diagonals are congruent, that is going to make all 4 of these pieces congruent. The last special parallelogram that we're going to talk about are squares. So squares, if you remember, the definition was that they are rhombuses and rectangles. So I'm going to look back at rhombuses and rectangles, and I'm going to have to use those same characteristics for the squares. So rhombus has all 4 sides congruent. So that's 1, 2, 3, 4. And opposite sides parallel. So parallel and parallel. Again, the angle characteristics for a square are the same as the rhombus and the rectangle. And so we know that they are all 90 degrees because they are all congruent. And lastly, the diagonal relationships. The diagonal relationships start to become a little more complicated in the square because I have a lot of relationships happening in the rhombus and the rectangle. So the first thing you'll remember is that the diagonals are congruent. So A, B, C, D, and let's see, we would say that AC is congruent to BD. But we also know that these diagonals cut each other in half. They bisect each other. So that's going to make the 4 diagonals, half pieces, all congruent. We then also know that the diagonals are perpendicular to each other. So there's that picture. Again, I'm drawing these on different pictures just so that it's a little clearer. You can see all the attributes, and but you could draw them all on one. It just starts to become a little cramped. The last attribute is that the diagonals bisect the angles. But we know that each of the 4 big angles in this square are congruent. So it actually turns out that all of these little angles are congruent to each other.